All right, let's talk a little tips on this OTI here. So 1.6a. First problem's just writing the inequalities. So we've got a y line, another y line. So like this would be all the values below negative, or sorry, this would be y is less than 4. This line here would be y is greater than negative 4. Both equal to because they're solid lines. These are x lines because they're vertical. This would be like x is less than negative, or sorry, x is greater than negative 4. This would be x is less than or equal to positive 4. So you just have to pick the right one that has those. Should be able to figure that one out. The main one I want to talk about was, I think it's this next one. Yeah, this little guy. So this is like the first example from our notes. The only difference is the way this graphing tool works is you have to have points that you can plot. So here's how I would do this problem if I was personally doing it. And then I'll show you another route you can go if you like that better. So if I'm doing this, I'm going to use my x and y intercepts. So I notice that when I plug in 0 for x, this term's going to drop out. Well, if that term's gone, then negative 7y equals 0 is just going to be y is 0 also. So I realize that I get 0, 0 as my x-intercept, which means it's also my y-intercept because it's the same coordinate. So for this problem, when I go to use my x and y-intercepts, I get that they're both at 0, which means the graph goes through the origin, but I need another point because I don't know where it goes. So what do? You go to what I always do. If I'm making a graph, I just need a point. So I'm going to pick a number to substitute into here and solve and figure out, okay, this will give me another point that I could use. So let's say we took like, I don't know, I could really use anything. So maybe we go 2 or 1 or 3 or anything. So if you put 1 in for your x, what you're going to notice on this one is you then have to like subtract this over. So you'd have negative 3, you divide it by the negative 7, and you get like 3/7. You'll notice this only lets you plot whole numbers. So we kind of run into a little bit of a problem there if we try to use our intercept or our points method. So that's not great. So what do we do if that's the case? Well, you go back to something that we've learned before. So let me show you what I'm talking about here. Oh, let me write the problem down. So if we have 3x minus 7y equals 0. Okay, go back to here. All right, so if we have this and we want to turn this into something we can graph, you can always turn it into a y equals mx plus b equation. So if I take my 3x to the other side, now I've got negative 7y equals negative 3x. Divide both sides by negative 7, and I've got y equals 3/7 x. And when we say a y equals mx plus b, that b value is technically 0 in this case. So I'm going to graph a line with a y-intercept of 0, which I've already done that piece. But now I do know my slope is just 3/7. So I could take from my y-intercept, and I can go up 3 right 7. So using all skills we've done before, or you've learned before, nothing crazy here, we're just graphing. So from my point, I can go, what was my slope? 3/7. So up 3, right 7. So that's going to be the coordinate. 7, 3. There we go. And if you haven't noticed, when you're plotting points, you can go look up here. Like this spot right here shows you the coordinate that you're at. Okay? So again, we're going to kind of run into the same problem here. So if we do the same route, I'll just show it to you again. Let me write it down. So we got 6x minus 7y equals 21. Okay, I'm going to go ahead and switch over. Let's convert it to y equals mx plus b. Quick and easy. So we subtract our 6 over 6x. So negative 7y equals negative 6x plus 21. So we're trying to get mx plus b here. Divide everything by the negative 7. So that's going to be 6/7 x. There's our slope. And that's going to be minus 3. So now we've got the y-intercept is negative 3, and the slope is 6/7. So I go to my graph, and I do a line. Again, y-intercept from what we just had there was negative 3. So this is what I'm talking about. Look up here. When you're plotting your point, you can make sure you're in the right spot. So y-intercept negative 3. And then from there, slope is 6/7. So we're going to go up 6 and right 7. So up 6 is going to put us at 3. And then right 7 is going to put you at 7/3. There we go. And then we're looking good. Okay? Don't forget about things you know how to do. That's what I'm seeing. A lot of you guys are kind of thinking, like, just because we do a lesson about one thing doesn't mean every single problem is going to be about that one thing. Like that's not how higher level math works. We don't just start doing 40 examples of the one thing we just learned. You have to use other tools you learned to figure things out. Because this is solving by graphing. It's graphing in standard form like we talked about in the notes, but also you can use graphing by y equals mx plus b. There's all different routes you can go. Okay? So don't think everything is going to be directly the exact piece of thing we learned. You got to use all the math you've learned to figure stuff out. So the solution was the spot they intersected. If you remember, that was at 7, 3. It says type it as an ordered pair. So 7, 3. Check your answer. Good job. Okay, so there's another one like that. There's one with inequalities that I was going to talk about. If the internet cooperates. Come on, little guy. Gotta love it. We'll pause. Okay, there we go. We're good. All right, so this is the example 2 from the notes. This is graphing all these inequalities. These ones we are going to be able to use our intercepts. These are really nice, easy to work with problems. So we have x plus y equals -4, or greater than -4. So when x is 0, y is going to be -4, because that would go away. So y is -4. That's your y-intercept. When y is 0, x is going to be -4. All right, boom, there's that line. So that one's going to be shaded above, so we're above here. We'll get to shading, how you shade that in a second. This one, x-intercept. So when you plug 0 in for y, my x-intercept is going to be 5. There we go. When I plug 0 in for x, my y-intercept is going to be -5, because -5 would give me the positive. Okay? And then the last line, y is less than 3. Easy. Horizontal line at 3. So go 3, go across, boom. Okay, so there's our 3 lines. Now, with the shading, our first line we graphed, we were shaded above it. This y less than 3 line is going to be shaded below it. So we're below this line, we're above that. So basically it's one of these 2 regions. This one actually is tricky. We didn't talk about this. Because the y is negative, if you remember how this works when you have inequalities, if you were going to try to get y by itself here, if you're going to get this into a y equals mx plus b, so you'd subtract the x over, but then you'd have a negative y. So you'd have to multiply both sides by a negative. And that, if you remember how that works, causes the sign to flip, which is why actually this one should be shaded above the line. And so our area that ends up being shaded in this case is this one. It's a pretty minor thing. Again, not a huge deal in terms of that. The other thing you can always do on these is you can pick a point. Like if you want to check 0, 0 and see, if I put 0, 0 into this, does it work? Yes, it does, because 0 minus 0 is less than 5. That's how I know it's on this side of the line versus this side of the line. So I always, 0, 0 is like a money point to always check so you know which way to shade on lines. So just things to keep in mind. All right, so I save that. Now, I purposely do not have this problem correct right now. I'm going to show you what happens. You click check answer, and I got it wrong. So I read this. You get by graphing boundary lines for each equation. Replace the inequality symbol with the equal sign and graph the resulting equation. So it's describing me how to do it. Then it says, recall that if the inequality is strict, use a dashed line. Now, that's what these are. These are strictly greater than or strictly less than. I didn't use dashed lines, so that's my error. So I go back, click, switch them to dashed, because every one of them should be. I save, I check my answer. So that's the kind of thing, like, that's why, if some of you guys are wondering why I'm using this software, is it helps you figure things out. It isn't just like, oh, submit a bunch of work and you don't know if you get anything right or wrong. If you really use it well and you put the time in, that's why I'm giving you 7 problems. So these are not super long assignments. Is you got to work through them. They're not just here's all the problems, here's 50 problems like what we just did. It's you have to think and try to figure stuff out. Lastly, don't forget about this stuff. The Help Me Solve This thing's awesome. It literally walks you through a problem identical to it, and as you click continue, it'll ask you to figure things out. So this will teach you exactly how to do one of these questions. Yes, it takes a little bit of time, but you can, and as you get them right, it advances you to the next thing. Or if you keep getting them wrong, it won't advance you. If I don't know what the right answer is, I'm not reading it. Apparently I'm really lucky. So as you keep doing them, if you get them wrong, it'll tell you what it is. And then you'd be like, oh, okay, I read that, it's supposed to be dashed. And it'll correct it for you, it'll let you keep going. So it walks you through the same type of thing, how to do the problem, how to solve it. Use this stuff, don't just send me, I don't know how to do this email. Sorry if this is going long, but I feel like I'm getting a lot of just people saying like it doesn't match anything we've done. Correct. It is not exactly like every example problem. Okay. So use the tools that are on here to work through them. That's why they're called OTIs, which is opportunity to improve. You're supposed to be learning from this too. It's not just practice. The practice stuff we do later on. All right. There we go.